Hi students, the next visible surface detection method is Z-buffer method. In the last video we have learned about backface detection, and the second method is Z-buffer method. It is also called depth buffer method. And about the Z-buffer method, it is an image space method. Image space method means it is implemented in screen coordinate system. And the basic idea of the Z-buffer method is to test the Z depth of each surface to determine the closest visible surface. So each surface is processed separately, one pixel position at a time across the surface, because it is a image space method. So the processing is in pixel by pixel coordinate system. And to override the closer polygons from the far ones, two buffers are used. And the first buffer used is depth buffer. The first buffer used is depth buffer, and it is used to store the depth value, that is the Z values. And the second buffer used is refresh buffer. It is used to store the intensity values at a particular point. And the viewing direction is taken as Z direction. When the viewing from Z, we have two options. That is, first one is we are sitting in the positive Z direction. Suppose we are sitting in the positive Z direction. Suppose this is the positive Z axis, and we are sitting in the positive Z direction, looking at the origin. This is our origin of our system, and viewing along the negative Z axis. This is our negative Z axis, this is our origin, and this is our positive Z axis. Our objects are in the negative Z axis. Our surfaces S1, S2 and S3 are the negative Z axis. From as the values, Z values, depth values are negative, the larger Z value is for this one, for the surface S1, and the smaller depth value is for the surface S3, as these are negative values. So the larger Z value will be closer, and the smaller Z value is further. The second case is that we are sitting in the negative Z direction. Suppose this is the negative Z direction, and viewing along positive Z direction. This is the positive Z direction. So the smaller Z value is for surface S1, and the larger Z value is for surface S3, and the smaller Z value will be closer, and the larger Z value will be farther. And we are writing our Z buffer algorithm based on the first case, that is sitting in the positive. We are sitting, the viewer is in the positive Z direction and viewing along negative Z axis. Okay. And now we are moving on to our algorithm. Our algorithm is that first we initialize the buffer, that is we initialize the depth and refresh buffer. That the depth is set as 0, and the refresh buffer, the initial value of the refresh buffer is set as the background value. And we will take each pixel, and for each pixel we will check the value, Z value for the surface, or Z value for the particular pixel that we have taken is greater than the already stored Z value. Then the depth of xy is stored as the larger Z value, because we are taking the case 1. In that case, the larger Z value will be closer, and the value of the refresh buffer is updated as the intensity value of that particular pixel. Okay, and this is our algorithm, and our next question is how to find the Z value. And from the plane equation, we know that ax plus by plus az plus d is equal to 0. We can obtain z is equal to minus ax minus by minus d by c. And our according to our Z buffer method, if you are able to find the Z value at xy position, then you can also find the Z value at x plus 1 y position, and also x plus 1 y minus 1 position. Okay, so if we can find the Z value at xy position, we can find the Z value at x plus 1 y position, and also x plus 1 y minus 1 position. So we are next going to study how to calculate the Z values in the other two positions. Okay. We are taking the first case, that is z value at x plus 1 and y. We know the z value at x, y, that is z value is minus ax minus by minus d by c. And now we are going to find the z value at x plus 1 y. For finding the z value at x plus 1 y, we will substitute x in this equation with x plus 1. So we will get z dash is equal to minus a into x plus 1 minus by minus d by c. That is z dash is equal to, by expanding and solving this equation, we will get z minus a by c. Next is we are going to learn is the z value at x plus 1 y minus 1. For that, we have to find the slope of a line. That is, suppose this is our scan line and we know the z value at x plus 1 y and xy and x plus 1 y. Next we have to learn, we have to find the z value at x plus 1 y minus 1. We will take x plus 1 as x dash and are going to find the slope. So slope of the particular line will be y minus 1 divided by x minus x dash. That is y minus 1 we will get 1. That is slope we will get m is equal to 1 by x minus x dash, and x dash can be written as x minus 1 by m. Okay, so x dash is our x plus 1 and we will substitute it in our first equation. In this equation, we will substitute the value of x dash and the value of the y as y minus 1. Then we will get z dash is equal to z plus a by m plus b by c. By solving, we will get the equation in this way. And the advantage of this method is it is the most efficient algorithm and also it is the one of the fastest algorithm for detecting the visible faces. And the disadvantage of this method is that we need to maintain two buffers. So this maintaining these two buffers, that is depth buffer and refresh buffer, is a costly process, which makes the method a expensive one.